Hello and welcome back to HW3.2. And maybe it looks like this. Maybe it looks like this. That's right. I haven't forgotten about you guys. If a triangle is a right triangle, then the theorem can be applied to find the side lengths. Let's see what the new version says. If a triangle is a right triangle, then the blank theorem can be applied to find the right sides, find the side lengths. Pythagorean. Some people just call it Pythagoras. If a rigid motion transformation, a translation, rotation, or reflection occurs, then the corresponding parts of the preimage and the image will be congruent because it's rigid. So like the side lengths are all the same and the angles are all the same, and if all the angles are the same and all the sides are the same, then the shapes are congruent. If triangles are congruent, then every corresponding part is congruent. They all have to match. Yeah. Wow, I'm so glad we retrieved. Perform the indicated transformation. In the other packet, you return the page. Let's see if it's the same problem. This is so fun. It's like level 3. The game has changed. Yeah, it's the same problem. Translate. Do we remember how to translate? Take the x coordinate, subtract 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I could recount this, or I could just go diagonal 2 and recreate the shape this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, can I confirm that yeah, look, this this point is 0, -4. That's a crazy tiny 0. Let's zoom in. Yeah, looks legit. And this is 8, -4. So yeah, those are 8 units apart in the x space, and the image is -8. Yes. Okay. But oh, it's supposed to go up to. My bad. Look at that. Mr. Abden messing it up. Even though I messed it up, I'm not going to erase it. I'm just going to call this the image. What's that other image there that you see? I don't know. It's not labeled. Okay, rotate the quadrilateral 90 degrees counterclockwise around the point 3, 1. Ooh, this is hard. This is hard. But we know that when you rotate 90 degrees, you're perpendicular. So all these slopes should be perpendicular. And I can swing this point down to here. That's not too hard. But then from that point, what do I get? What's perpendicular to -1/3? -1/3. Flip the slope to +3/1, which would go this way, which I know that's the wrong way. So now I'm going to double negative, which double negative is positive. Okay, what about this slope? It is -1, 2, 3, 4/1. -4. So it's going to be +1/4. Which way is it going to go, though? To the left? Okay. Alright, that's making sense. +1/4 ending up here. So I have to do double negative again. -1, back 1, 2, 3, 4. But that's a +1/4 slope. Okay, this guy is down. What is it? Also, oh, it's parallel. Yes. Okay, good. Then it's also just a slope of 3. Sweet. This is parallelogram. Done. Crushed it. That was fun. That was a good one. Hope you all had fun with that. And now the homework begins. Consider the given statements and fill in the blank with something that makes sense. The first comparison demonstrates a relationship, and the second comparison has a blank for you to fill in based on the relationship provided. There may be more than one logical way to fill in of the blank. For example, in the statement foot is to boot as hand is to blank, you would consider the first part of the statement foot is to boot. Think about the relationship. It is apparent that a foot can go in or wear a boot. Logically, then it would make sense to fill the blank with glove, since a hand can go in or wear a glove. So pencil is to writing, so pencil is what you do to write. Violin is what you do. What do you do with a violin? Fishing is to lake, as soccer is to, well, where do you fish? You fish in a lake. Where do you soccer? All right, you get it. This should actually be like same slope. Okay, decide if the following statements provide a true logical conclusion or if the statement is false. If false, provide an example. These boxes are unnecessary. Oh, how do you spell unnecessary? Necessary, I think. Okay, whatever. Should look that word up. Can't, I'm in a hurry. See, look, in the other packet there's no boxes. An acute triangle only needs to have one acute angle. Can you draw an obtuse triangle with one angle? Give it a shot. Because let's read the directions again. Shall we? Decide if the following statements provide a true logical conclusion or if the statement is false. If false, provide a counterexample. So draw a picture that shows it's false. Okay, and finally, well, not fine. Many diagrams have a history and progression to the way they are created. For each diagram, list the steps in the order that you think they occurred to make the diagram. Okay, if you don't know what we're talking about, go back and watch the lesson again. It's a 20-minute video, but it's a good one. Then make a conjecture about the piece of the diagram indicated. So they're going to indicate a piece. You make a conjecture about it, but after you list the steps. Consider using a compass and straight edge to reconstruct the diagram as you work. So can you remake it? Finally, write an argument that can be used to justify to someone that your conjecture would be true. Wow, that's a lot. I believe in you guys, though. Interesting. So one thing to keep in mind is because C is on the rim of circle A, you can't have point C until you have circle A. So you can't have circle C. And so what does that tell you about point E? So where does it start? The first couple of steps, sometimes, as you saw in the lesson, there's like multiple ways to get started. But then once you get started, like there's only a couple ways to finish usually. There's like a last. So don't worry about it too much. Just kind of get the feel for it. Say in general, what is the steps? So quadrilateral ACED. What is that? Is that a square? Maybe you could conjecture that's a square. Good luck on the justification. Actually, you could make a fake justification that that's a square. It would be wrong, but that's fine. That's what other mathematicians are for, to tell you when you're wrong. Oh my gosh, is that a square? How could you prove it? Maybe using triangles. Congruent triangles. Interesting. Something, that's a good one. What came first? What came first? What came last? What was the last points to be found? You can't make a circle till you find where its center goes. But you can always pick a first circle to make just randomly and then find the next center after that. But, okay. Examine the diagram and add any information that is given to the diagram. Make a plan for finding the value of x and follow your plan. Okay, is that just Pythagoras? Oh no, this one's kind of interesting. Yeah, use algebra. Remember, the straight line equals 180, but they say ABC is 90. What does that tell you about these two angles added up to find x and do an algebra? This one's really good. Okay. Here, there be decimals. So don't freak out if your answers are really decimally. Did they change the numbers from the previous one? Nope. Same numbers. Same decimally numbers. And then for the go, there's a bunch of moving things around. Yeah, you're gonna make. You're gonna draw the connecting lines. Cool, cool. Yeah, when it says draw C prime, that means connect point C and point C prime. Just connect a point in the pre-image to the point in the image. Fun. Good times were had by all. And I believe that's it after that. Yep, because I'm running lesson 3. Okay, I hope you had a wonderful time and a great weekend, and I'll see you on Monday. Or Tuesday or Wednesday, depending on when you watch this video. Okay, bye.